Okay.
So the homework was just like review. The whole chapter was review for the exam.
Right.
Um, I think I got it, but honestly, I might need a little help with this quiz since I missed a lot of last week's.
Okay.
But I will do my best. So do you want a quiz?
Yeah, I'm already there.
Me too. So
Okay.
questions. Oh, sorry. So question 2, given a 90% confidence interval of 105 for mean heart rate, da da da. That one's that we are 90% confident that the true mean heart rate is between 45 and 105, right?
Yes.
Sweet.
Okay, so use the following information to answer the next two questions. Researchers at the University of Mississippi wanted to determine whether the reaction time in seconds to go, no-go stimulus of males differed from that of females. The researchers randomly selected 20 females and 15 males to participate. The go, no-go stimulus required the students to respond to a particular stimulus and not to respond to other stimuli. The researchers decided to construct a confidence interval to determine if the difference of the means is significant. To determine whether the confidence interval would be reliable, they created a QQ plot of both random samples and see what they are approximately normal. Oh, and see that they are approximately normal. Are the requirements for the constructing a confidence interval satisfied? Why or why not?
Yes.
I think it's yes, and it's because the distribution of the mean of each sample is normal, since the data has been determined to be normal.
I say I would agree.
Okay.
Oh, sorry, it just kicked me out of the quiz for a second.
Oh, nice.
Yeah, let me get back into it real quick. Hopefully that wasn't my first. Oh, okay, quiz. I was like, oh no, what if that was my first attempt? Okay. All right, I'm ready. Of the 4 types of confidence intervals listed below, which one is appropriate for this experiment? Um, confidence interval, mean differences. And
I think it might confidence interval for you when omega is an unknown.
is unknown.
Unknown. But I could be wrong.
Yeah, I don't know.
A researcher is interested in estimating the savings account balance of customers at a large bank. She obtains the savings account balance of a random sample of 30 customers. A 95% confidence interval for the mean savings account balance of bank customers is found to be $34,002.08 and $4,142.75. Which of the following would produce a confidence interval with a smaller margin of error than this 95% confidence level interval?
Balance of.
Is it a compute a 99% confidence interval rather than a 95%?
Yeah, wait. obtain the balance of 90 bank customers. Well, you could also do obtain the balance of 90 bank customers within 30, because 30 is the number, so that's the denominator, right? And if you increase the denominator, huh?
It's the square root of 30.
Oh yeah, right. But isn't it still divisible? Isn't it still in the denominator, or is that a completely different equation I'm thinking of?
According to the notes, a confidence interval is the interval estimator used to give a range of plausible values for a parameter.
Mm-hmm.
The width of a confidence interval depends on the chosen confidence level and its correspondence value of z, as well as the sample size n.
Yeah, so I think, sorry, go on. I'm sorry.
All it says is this is the equation.
So I remember reading something about it. I'm going to go ahead and put 90 instead of 30, and then you can do the 99, because I don't know if that one's wrong or right. That one could be. But I really that it's the 90 instead of 30, because like increasing the population size helps you to, you know, have better information, and they're more accurate.
Right.
And then increasing the denominator makes the end result smaller, and so, or, you know, so maybe there's difference by that. But I'm not 100% confident, so if we get it wrong, then it's probably yours.
99% and you do the 90, and we'll see who's right.
Sounds good. A factory makes propeller drive shafts for ships. A quality assurance engineer at the factory needs to estimate the true mean length of the shafts. She randomly selects the drive shafts made at the factory, measures their lengths, and finds their sample mean to be 1,000 millimeters. The lengths are known to follow a normal distribution whose standard deviation is millimeters. Calculate a 95% confidence interval for the true mean length of the shafts. Input your answers for the margin of error, lower bound and upper bound. So margin of error for the 95% confidence interval question has been the death of me.
That equation is z times omega divided by the square root of n.
Get my paper real quick. A pencil here. You give me. I know I played with it last time. Okay, so what? I'm sorry.
So the equation for the margin of error is m equals z times omega divided by the square root of n.
Omega divided by the square root of n. Sweet. Okay.
So what's z? Or
That's not
where we
z,
use the
is
normal?
it?
Is that the normal? Where is it? The normal probability applet?
And with the not the normal probability applet, but the other one.
That would be the t. We're talking about z squared.
Oh, yeah. I'm sorry. Yeah, it's right here. So we put 95% in it.
Yeah. So the z-score would be 1.960.
So am I highlighting the upper? Oh, so it would be the z. Wait, the z-score would be 0.063. Did you get that as well?
That's if you put it in the wings.
Oh, but you need it in the middle, is what you're saying.
That's what I'm guessing.
Okay. Yeah, I'm not getting a different. Okay. So 1.96 is what you're saying?
Yeah.
Okay.
And so that's the z-score.
And then omega is, wait,
2.
n. Omega is 2.
And n is the square root of 4.
Oh, I'm like on the, okay, yeah.
So we've got 1.96 times 2 divided by square root of 4. I have 1.96.
Divided by square root of 4.
Because 2 divided by the square root of 4 is, the square root of 4 is 2.
Yeah, I got 1.96 as well.
Okay.
And the
So that would be the x bar minus,
yeah, x bar.
so that's the 1,000, right?
Yeah, x bar minus z. It's
Yeah.
it's the x bar minus z with beta divided by the square root of n.
It's x plus or minus,
Yeah.
yeah,
Okay. So 1,000 minus 1.96
right?
divided by
1,000
2
plus.
and the square root of 4. I don't know if I got that right.
So it would be 998.04 and 1,001.96.
Okay, well then maybe I did get it right.
That's what I got.
Okay.
So the lower bound is,
Yeah,
I
I
don't,
just got the lower bound. It was so, I was like, oh.
998.04.
And then if we get these wrong, maybe we'll try the z-score of a wing or something instead of the center. But
Yeah.
I think this is right. Hopefully. Okay. To assess the accuracy of a laboratory scale, a standard weight what is known to weigh 1 gram is repeatedly weighed a total of n times, and the mean of the weighings is computed. Suppose the scale readings are normally distributed with unknown mean u and standard deviation 0.01 grams. How large should n be so that a 95% confidence interval for u has a margin of error of 0.0001? So this is kind of doing the equation backwards, right?
Yeah. So it would, instead of it would be m equals z times omega divided by the square root of n. So now you're doing 0.0001 equals, do we know the z-score?
Equals,
Or is that 1.96?
yeah, if it's a 95% confidence interval, it'd be the same, right? 1.9.
1 divided by the square root of n.
So square 0.001. Or actually, we should just divide. It's divisible, divided by, okay.
Divide.
I'll stop talking. We can both do it. Yeah.
It's divided by the 0.96, right?
Yeah, onto the other side. And so then it would equal
0, 0, 0, 0.
and then it'd be multiplied by and then all of that would be squared, and that's what equals n. So,
Okay.
yeah.
Times 0.01 squared. I don't know if that's right.
I don't know if that's right either.
Because I got 2.60304e negative 13, which means that there's like 13 zeros or 12 zeros in front of the 2.
Yeah, that's totally wrong then. Maybe it's more of a logical question. And B, so that 95% confidence interval for U is a margin for O.
Let's try in the wings 95%. Which
Okay.
is 0.63. So it's only 0.06.
0.6. No, it's still to the exponent of like negative 10. This was the axis.
See, and the answer that I got was 0.000000000003.
Yeah, I got 2.5 times 10 to the negative 10th exponent. So probably pretty much the same. I don't think that's right. Because that it's like how many times are you supposed to weigh it in order for, and you can't just say 0.0003 times, you know?
Right.
So I just gotta think about it for a second. How many times do we have to weigh this 1 gram?
We take z times omega over m and square it. N equals z times O divided by m, and that's all squared. So n equals 1.96 times 0.01 0.001 squared. So let's try that.
So what is n? You put
I got 38,416.
that might be right, because you'd have to have a big number in order for the margin of error to be, only 0.0001.
Right, so you'd need a larger portion.
So what was it?
38,416.
Okay. And you did that with the 0.063 as the z?
No, I did the 1.96.
Oh, okay.
I wonder what it would be if I did the 0.063. Let's see. That would be 39.69.
So I guess we'll just run through it again if we get these wrong and do
Okay.
it. We'll switch it. Only other way I can think of doing it.
All right.
And then we'll also know if we get the questions before it right, that's the right, that was the right interval to use. We just did that one wrong. So we'll just see.
Okay.
So the mean area use of the several thousand apartments in a new development is advertised to be 1,250 square feet. A tenant group thinks that the apartments are smaller than advertised. They hire an engineer to measure a random sample of apartments to test their suspicion. The null and alternative hypothesis HL and HA for U are. Tenant group thinks the apartments are smaller. So they think that it is less than. So I say,
It's the last one.
yeah, the last equal to 1250, and then it's less.
In a statistical test of hypotheses, we say we reject the null hypothesis with a level of significance A if it's less than A, if the p-value is less than A.
Yeah. Oh, yeah. Okay. A group of statistics students to determine if students in some apartment buildings get better grades than students in other apartment buildings. They collect GPAs from an anonymous random sample of size 15 each of 4 different apartment buildings. The data for each apartment building are bell-shaped with no outliers, and the sample variations are nearly equal. And they use a ANOVA hypothesis test to answer their question. What's an ANOVA hypothesis test?
That was one of the tests that we had to do last week. It's similar to a t-test, except it compares multiple data, not just two.
Okay. So I guess this one collects multiple data because they're doing 4 different apartment buildings
Right.
and 15.
So I would say yes, it is enough that the data for each apartment building are bell-shaped with no outliers, and the sample variances are nearly equal.
Yeah, the next yes doesn't make much sense. Okay, 13.
A medical researcher is working on a new treatment for a certain type of cancer. The average survival time after diagnosis for the standard treatment is 2 years. So the null hypothesis is that average survival time after diagnosis is the same for the new treatment and the standard treatment. In an early trial, she tries the new treatment on 3 subjects who have an average survival time after diagnosis of 4.5 years. Even though the sample is small, the results are statistically significant at the 0.05 significance level. Consequently, she rejects the null hypothesis. In a future study, it is determined that the new treatment does not increase the mean survival time in the population of all patients with this particular type of cancer. The researcher has committed an error. She's committed a type 1 error.
Type 1 means regrettable hypothesis. Right?
That means that she rejected the null hypothesis when in reality the null hypothesis was true.
Okay, good. All right. If the level of significance beta is made very small, thereby making the probability of committing a type 1 error very small, what happens to the probability of committing type 2 error increases. Reducing the probability of completing a type error, we increase the probability of committing a type 2 error.
Yes. It increases.
Yeah.
So by reducing the probability of committing a type 1 error, we also reduce? Or do we increase?
Increase the probability of committing type 2 error.
Okay.
I think. I'm pretty sure.
I think you're right. Number 15. The nicotine content in cigarettes of a certain brand is normally distributed with mean in milligrams U and a known standard deviation of 0.17. The brand advertises that the mean nicotine content of its cigarettes is 1.5, but measurements on a random sample of 100 cigarettes of this brand gives a sample mean of X equals 1.53. Is this evidence that the mean nicotine content is actually higher than advertised?
That's the hypothesis.
Well, so the hypothesis is U equals 1.5 and the alternative is U is greater than 1.5. But at the 0.05 level of significance. So because it's less than a 0.05 level of significance, we reject the null hypothesis. Right?
Yeah, so HO. Yeah, it was.
So we reject
If
HO.
it's low, reject null. I think there was some kind of riddle that said something like that. So I think it's right. Computer
Okay.
isn't saving them though. That's weird. It's not saving my answers. You would like to look at the mean number of hours worked for wage per week by male students and female students. You would like a random sample of 100 for each group and test if means are different. What is the correct statistical procedure? So,
An independent samples t-test.
awesome. Are you using Wi-Fi?
What?
All right. I have really bad internet, and sometimes if more are using Wi-Fi,
Oh.
it's slow. I'm asking my husband if he's using it. Sorry. My questions
You know
aren't
what?
safe.
I do the same thing with my kids. I tell them, get off the internet.
It's like I put in my last 3 questions, but I always save after, and they're not saving, so must be something. Okay. All right, question 7. Oh,
And
all
you want
right.
me to read it?
Yeah, you're good.
An educator is interested in academic achievement by males and females with similar academic support systems. She decides to use brothers and sisters raised in the same home. Furthermore, she decides to use only brother-sister pairs when they are next to each other in sibling order. Should she use a hypothesis test based on independent or dependent sampling?
It's not very randomized.
No, it's not. I think it's an independent sampling because knowing the brothers included in the study tells you nothing about which sisters are included. Well, no, because it does.
Yeah, it does. So it is dependent because the first column is intact with the second column. Like it's the brother and the sister, they go together.
So it's dependent sampling?
I think maybe I don't remember
The
the
sisters'
sister's
academic
academic.
achievement. But see, the sister's academic achievement does not
It
depend
doesn't.
on her brother's academic achievement.
Let's see, compare. If you select a brother so as to compare his academic achievement to his sister, you must include the sister in your study.
Or independent sampling, the brother and sister are separate people who make their own choices. So the brother's academic achievement shouldn't depend on the sister's academic achievement.
Yeah, that's it.
That sounds right.
That does.
This is hard.
This is the longest tab, 32 questions.
Oh my gosh.
18. Halfway there. Okay. A soil scientist collected random soil samples from a field and measured the dissolved organic carbon level of each sample. Measurements are recorded in, oh no, open this up. A researcher would like to construct a 95% confidence interval for the mean dissolved organic carbon level in the field. Of the 4 types of confidence intervals listed below, which one is appropriate for this situation? Is the beta known? What did we do for the first one? We said the confidence interval of U and beta is unknown, is what we did for the first one.
I think so.
This one is soil scientists.
It's still opening for me.
Yeah, mine is. But this one, this question we don't need it for.
So do we do the confidence interval for the difference of means using independent samples? That doesn't know unless there's more than one sample.
Oh, I guess we'll see.
But see, they collected multiple soil samples, but only from one field.
Yeah, so
It's not going to be either one of those.
it's either when beta is unknown, is known.
Well, because the true mean we don't know.
Yeah.
So I would think it's when beta is unknown.
the margin of error for this 5% confidence interval.
Okay, so let's get some statistics.
Yeah. Is it the Analyze Explore?
That's what I'm doing.
Okay, I was just making sure I was doing the right one. Okay. So are the next two questions on the lower bound and upper bound? I'm going to put those in. Those are right here. Do you know how to compute the?
Level. That's
Yeah.
or the
Oh yeah, the equation.
margin of error is the m equals z times
Okay.
the o, which is is o the standard deviation or is it the mean?
What is beta? So it's the mean, right?
Is it the mean?
I don't. I don't remember. No, I think it's the standard deviation.
Okay.
Yeah, it is standard deviation. Yeah, it is. It is right.
Square root of 100. No, it was 20. Okay, let me see. And the margin of error I got was 1.896.
For equations, is it always just going to be 1.96 for the conference for Z?
That's what I think so. I watched another group's video, and that's what they put.
Okay. The lower is 11.168, and the upper is 15.
0.217, right?
Sweet.
Okay. Oh, now we're doing something else.
Of course. It's going to take a while to open. My computer being so weird, I'll save the answers to my questions. I'm scared that if I said it, that it's going to show that there was no answers.
Well, at the end, you can always save all the answers.
Yeah.
A random
Oh,
sample of
wow. This
Hummers
is a big
in
one.
Los Angeles and New York were taken from listings at cars.com. The data are recorded in used Hummers, New York, and LA.sav. We want to know if there's a difference in mean listing prices between Hummers for sale in Los Angeles and Hummers for sale in New York. Create a 95% confidence interval for the true difference of mean listings. So that we need to transform auto recode, and we're going to do what are we going to do? Cancel.
Transform auto recode. And you're going to do the price.
No, I'm trying to figure. city. That's what. Transform auto recode city.
City.
And that's just group.
And then
Click OK, and it'll automatically do it for us.
did you write something for the new name?
I put group.
Oh, okay. That's what you were saying. Okay. Got it. Sweet. Okay, what was the question again? 4 types of confidence. Oh, this one again. Which one is appropriate for this situation?
It's going to be the confidence interval for the means of the differences using independent samples, because the prices of the cars in LA does not reflect the prices in the cars in New York.
Yes. Okay, calculate the 95% confidence interval for the true difference of mean listing prices between Hummers, LA, and New York. Input your answers in the lower bound and upper bound. Oh. So analyze. So for the dependent list, is that we're going to put price in there? Or, oh, you can. And then factor list, are you going to put city? What did you put for your dependent list?
My dependent list. What do you mean?
Like when you go analyze, explore, and then you put in what you want explored.
Except you're not going to do. Are you going to do explore?
Oh, because I thought we were trying to figure out the lower bound and upper bound.
So your dependent list is the price. Factor list is the group.
The group.
Options. Plot. Normally plots.
What did you do with? What? Sorry.
What I did at the before was I did independent, an independent t-test.
Oh. Of all of them combined?
Well, yeah, sorta.
Well, I mean, I'm not saying that's wrong. I'm just wondering if that's what you did. So I can do that. Should I do that?
You can. It's you go to analyze and go down to compare means.
And then the one sample t-step.
No, the independent samples t-tests.
Oh.
And you're going to put price in the test variable.
Price.
And the
group.
In the grouping value, you're going to define. Sorry, I'm shaking. In the grouping variable, you're going to put your group. You're defining the groups as group 1 and group 2.
Define groups. So group 1 is just type in group 1 and group 2.
Yeah.
Okay.
And then when we get that, we always use the equal variance is not assumed.
Equal variance. So I still got two different lower and
You what?
doing that I still got two different lower and upper intervals.
Right. So we use the bottom one, the one that says equal variance is not assumed.
Oh, okay. Okay. I get it now. So negative 423.158.
Yep.
Thank you for walking me through that. I was so lost.
That's okay. I think that was part of last week's. I don't remember.
Yeah, they're all mixed in together now.
Seriously, right?
Yeah. Two, 5, 6. All right, and then on to a whole nother SPS.
Yeah.
Okay, many studies have suggested that there's a link between exercise and healthy bones. Exercise stresses the bones, and this causes them to get stronger. One study examined the effort of jumping on the density of growing rats. There were 3 groups. Rats were selected at random for the 3 groups, a control with no jumping, a low jump group. The jump height was 30 centimeters, and a high jump group 60 centimeters. After 8 weeks of 10 jumps per day, 5 days per week, the density of the rats expressed in milligrams over centimeters cubed was measured. The data are recorded there. Okay. Researchers would like to determine if the mean levels of the bone density are different between the 3 different groups of rats listed above. And then 0.05 is our level of significance. So is this this is ANOVA, right? Because it's 3 groups?
It is an ANOVA, yes.
Okay. I'm opening SPS now. And so, and then we're getting the test statistic. So is this just one sample t-test, or is this independent samples t-test?
It's an ANOVA.
Well, oh, so you do the one-way ANOVA for in SSPS.
Yes.
So you click one-way ANOVA.
Right.
Okay. That makes sense now. What do you put as the factor?
Let me think about it. You put the rat, what is that?
Rat bone density as the dependent list, right?
Okay, so what you do is you go analyze, compare means, one-way ANOVA. You put the rat bone density in the dependent and the group in the factor.
Oh, so you have to make a group first.
Yes,
Okay.
you have to transform it.
So transform, and then you go into automatic. Sorry, or I'm sorry.
And then when you're doing it, make sure you go into the options.
Wait, so you click transform and then what?
Oh, wrong one. Hold on. Okay, transform, auto recode,
Okay, that's what I thought.
and you're going to put the treatment over in the variable.
And then new name groups. You were saying something about options or just or
Don't use the red handled ones. Those are just for fabric.
analyze, compare means, one way ANOVA, and then density list and groups in the factor list.
And then
Okay, I'm finally.
you have to go into the options,
Oh, okay.
and you have to click descriptive and means plot.
Options, descriptive, and means plot. And then continue. Okay. And so the question was, what is the test statistic?
That's going to be the F.
So
And then
7.
testing, that's 7.978.
Yeah.
And the p-value is going to be 0.002.
So which of the following best expresses the conclusion of the test? Use a level of beta or alpha equals 0.05.
Hey, Jean, I need to call you back. I'm in the middle of a class. Oh, okay, bye. Sorry, it was my husband.
I like the song you have for your ringtone.
Yeah.
All the groups are different. What was?
So there is sufficient evidence.
Yeah, because it's bigger than 0.5.
At least one of the groups is different. So it's the second from last.
Okay, last one with the last SSPS.
Okay. Pressures of supply and demand act directly on the prices for airline tickets. As the seats available on the plane begin to fill, airlines raise the price. If the seats on a flight do not sell well, an airline may discount the tickets or even cancel the flight. A study was undertaken to determine if there is a difference in the mean cost of an airline ticket purchased 90 days in advance of a scheduled flight compared with a ticket purchased only 14 days in advance. Data were collected on the cost of a one-way ticket from London's Heathrow Airport to a variety of destinations in Europe. The lowest published ticket price of a one-way flights from Heathrow to various destinations in Europe was recorded for each scheduled flight 90 days in advance and then again in 14 days in advance.
Okay.
Test to determine if there is a difference in the mean cost of the nonstop flights when tickets are purchased 14 days in advance compared to 90 days in advance. Use a level of significance of 0.10. For the next question, do 14 to 90 days for the analysis. So we're going to do an independent samples test, right?
Yeah.
Does that sound right?
Yeah, it's either that one or
Because the price
one.
of the 14 days does not influence the 90 days and vice versa. Right?
Right, but it is if it's sold or not. You know, I don't know.
So analyze.
Okay. So the variable 14 days and 90 days?
No. I have to think for a minute. Okay. It's going to be paired samples. It's going to be a paired sample t-test.
Paired sample t-test. So then for variable 1 would be 14 days and variable 2 is 90 days?
Yes.
Okay. So the first question is, what is the test statistic?
I think it's 0.780. I think.
Well, if you scroll down, the T is 1685.
Where's, oh, I guess I need to scroll down. Then that's their variable, 1.685.
Okay. And then the p-value, where is it?
Is 0.000.
Oh, 0. All right.
And because it's less than 0.100, there is sufficient evidence to conclude that there is a difference in the mean cost of tickets purchased 14 days in advance compared to 90 days in advance.
Well, So it is rejecting the null hypothesis, because the null hypothesis is that the prices are equal. Oh
So
yeah, and so because that one's bigger, the null hypothesis is wrong. I thought if the I was bigger, the hypothesis was right.
let's see. Oh. Well, I got 80%. I'm good with that.
So wait, which one did you put for 32?
32. It's the second one.
All right. Mine's not saving my responses. Do you think if I submit the quiz, I will be okay?
They will automatically save, yeah.
Okay. It stopped saving them at question 13.
Nice.
So computer's being really weird right now. Makes me feel like I need to take pictures of all my answers in case it logs me out of the quiz again real quick. Okay, well, you can go and get back to whatever you're doing. I'm so sorry I was late.
That's okay. That's okay. At least we got together.
Yeah. Thank goodness. So are you going to
Yeah,
post on that thing, the link or whatever?
yeah, I'll do that.
Sweet. All right. Well, thank you for
Thank
meeting with me. Sorry about last week.
No worries.